There are 12 notes to an octave, and just to make things simpler, I'm going to use octaves from C to C. So, since the MIDI pitch for middle C is 60, in order to find out what the MIDI pitch for G sharp, we would have to count how many steps are in between middle C and G sharp, which happens to be 8. So that's just 60 plus 8, and that makes the pitch 68. All you have to do after that is plug in the equation, and then you end up with 415 Hertz. If you remember, an octave above a note is exactly twice the frequency of the original note. If you rearrange this equation, it's the same as 2 to the 1/12th power. 1 over 12 stands for 1 out of the 12 notes in an octave. So if you take the ratio of an octave, 2, and raise it to the 1/12th power, you will find the interval of frequency between each note. Take that interval, which should be around 1.059, and raise it to the number of steps in between each note, and you will have a new frequency of a new note. Most musicians are trained to tell by ear whether or not a note is in tune or not, and what that basically means is that if the frequencies don't match up, then the instrument won't be in tune. For example, right now my piano is in tune because it's set at 440, just like the standard should be. If I change the frequency of the tuner to something lower like 416, you can easily tell that the note's not in tune with the piano. Shows two harmonic notes, G and C. The reason why these notes sound well together is because their ratio is very small. If you notice, every third wave of G matches up with every second wave of C, noted at the circled places, creating a frequency ratio of 3 to 2. Whereas on the bottom, the notes C and F sharp have no pattern and do not meet up anywhere, and therefore are cacophonic to the human ear.